Welcome to video 2, Logarithmic Graphs. I've given you a lot of notes here on this page, so you're probably going to want to stop the video, do the sketch in your composition notebook, write the definition of a logarithmic function. I want you to note that a logarithmic function is the inverse of an exponential function with the same base. That's going to be really important when we begin to graph this. You can see that the graph here in blue is exponential. It's growth, goes through the point 0,1. The logarithmic graph, you'll notice in the red, is an inverse. It is a reflection over the line y equals x. In essence, what this is it switches all the coordinates of x and y. That's how you form the inverse. It also switches the domains and range. And in this case, both functions, the red and the blue, are both functions. Be sure and get this information into your composition notebook. To graph a logarithmic function, you're going to begin with the exponential function that has the same base. We're going to switch the x and the y coordinates of the exponential equation to obtain the points for the log function, and then you'll find the domain and range of the log function. So starting in blue, if I'm going to graph the log function, log to the base 2 of x, I'm first going to graph the exponential with the same base. So I have 1/4, 1/2, 1, 2, and 4. And if I graph that in, can't talk and graph at the same time, here's your exponential function. This is 2 to the x. Right, in order to graph the log, you're just going to switch the coordinates. So instead of x being -2, the y is -2, and so this is now 1/4, 1/2, 1, it's really small, 2, and 4. So instead of the point 1, 0, we're going to have the point, the point 0, 1, we're going to have the point 1, 0 in the log. Instead of 1, 2, we're going to have 2, 1. So this function, and as we get half, we get a little closer, a little closer. So you're going to have a function that looks like this. And this is the log base 2 of x. Once again, you'll see it's a reflection over the line y equals x, and the domain and range change. So in an exponential function, right, in blue, the domain is all reals. The range is from 0 to infinity. The asymptote is the x-axis, which is y equals 0. For the log function, the domain goes from 0 to infinity. You can see that it starts here at 0 and goes towards infinity. The y, on the other hand, is all reals. So you'll note they are inverses of each other. The x's and y's are switched. The domain and range are switched. And also the asymptote now is going to be the x-axis, or the y-axis, which is x equals 0. So note how the two are related. It's very important. Just like an exponential function, use transformations to graph, like the equation that I've put up here at the top. You can see that the negative out in front is a reflection. This is the initial value, the 3. 2 is the base. X is the exponent. -3 takes it to the right, 3. And +1 goes up 1. So this is the stretch or shrink, the a, that's in front of it for an exponential. In the log, it's the same way. If you have a minus in front, it's a reflection over the x-axis. A in front of a log stretches or shrinks the graph. The base b, log to the base b, of x, the plus or minus c, it's in parentheses, does left or right. If it's plus, it's left, and if it's minus, it's right. And then outside the parentheses, either at the beginning or the end of the equation, just like we talked about before, is up or down. And you use these transformations to graph a basic log graph and then move it right, left, up, and down, or reflect. Here's an example of using transformations to graph the log function. All right, so the first thing we want to do then is we want to make a table, and we want to put some points that we will use to graph the log. So we have x, and then we're going to use 2 to the x because this is log to the base 2, and then we are going to switch those coordinates and do x and then log to the base 2 of x. So I'm going to do just the basic ones that we did before. 2 to the 0 is 1, and 2 to the 1 is 2, and then I'm just going to switch those two for the log, and I'm going to just graph the log. So I'm going to go over 1, 0, this is just log base 2, and then I'm going to go over 2 and up 1. Alright, so in the blue, this is just the log to the base 2 of x. Alright, but this has a transformation, and my transformations inside the parentheses controls right and left. It's negative, so it's going to move to the right 1. The plus 2 on the end takes the thing up, the whole graph up 2. Right, up 2. So I'm going to change colors, and I'm going to move my, I'm going to move first my asymptote, because on a log function, right or left changes my asymptote from x equals 0, right 1. So the asymptote is going to go here. That's my new asymptote. Okay, this point right here goes to the right 1, to the right 1, and up 2. So this point goes here. This point right here, which used to be at 2, 1, goes right 1 and up 2 here. So my new function is going to be this one, which looks very similar to the other one. It didn't have a stretch or a shrink, but it has moved to the right, and then right 1 and up 2. One final thing, let's talk about the domain and range of a log function. If you'll notice here, the domain of the log of the graph that we're trying to do here, the domain starts at 1 but doesn't include 1 and goes to infinity, whereas the range is all real still. The transformation did not change the domain and range. Now here's an important thing to consider when you're considering a logarithmic function. If you look at the graph here, you'll notice that the x values for the red go from 1 to infinity. So that means that all of these x values do not exist in that function. They do not exist. So if you were looking in a calculator, those would have the word error next to them, because the log does not exist. So also what you need to notice here is that you cannot take the log of a negative number. Why? Well, there's no graph here. Graphing is a visual representation of the set of numbers that makes this equation true. So none of these values from 1 to negative infinity for the x will yield a valid value in this function. This is huge to remember. That's why we have to know what the domain and range are, because if you don't know what the domain is, you won't know what data actually fits into that equation. So on today's homework, I'm going to give you a problem on the next screen, and I want you to have that graph completed. I want it to be the best graph you've ever done in your life, and I will be checking. So here's your problem that I want you to copy down. You'll have to either use graph paper or have a very nice graph. I want you to do sketch both the graph, exponential graph 3 to the x and log to the base 3 on the same set of axes. If you could also sketch in the line y equals x to show that they are inverses of each other, that would be terrific. And I will see you in class.